is a huge subject, and much of it's not going to be covered in this book, and you may get a little frustrated as you're reading it because it'll say that it's beyond the scope of this book or beyond the scope of this chapter, but hang in there. One of the most important skills a network administrator needs is mastery of the access control list, or the ACLs. Administrators use the ACLs to stop traffic or permit only specific traffic while stopping all other traffic on their networks. And this chapter that you're going to go over includes an opportunity to develop your mastery of ACLs with a series of lessons, activities, and lab exercises. Typically, network designers use firewalls to protect networks from unauthorized use, and firewalls are either hardware or software solutions that enforce network security policies. What you're going to use is ACLs to control the access. And an ACL is just a sequential list of permit or deny statements that apply to addresses or to upper layer protocols themselves. ACLs provide a powerful way to control traffic into and out of your network, and you can configure the ACLs for all the routed network protocols. The most important reason to configure your ACLs is to provide security for your network. This chapter is going to explain how to use your ACLs in standard and extended versions as part of your security solution, and it's going to teach you how to configure them on your Cisco routers. Included in this chapter are going to be tips, considerations, some recommendations, and general guidelines on how to use the ACLs. Your ACLs enable you to control traffic into and out of your network, and it looks at the handshakes between your PC and your server. We're going to look at here at a typical TCP conversation, and again you can go through this on the online portion and watch it for yourself, but we're going to play this right quick, and you're going to see the acknowledgments and the synchronization and then the finished statements. Recall that TCP provides a connection-oriented, reliable byte stream service, and the term connection-oriented just means that the two applications using TCP must establish that TCP connection with each other, and they do that through the synchronization and the acknowledgement and then the finished statements. TCP data is full duplex protocol. Also, the TCP data segments can also be identified through the different ports that are used. So there are different ports that you need to make sure you understand. You have 0 to 1023. Those are your well-known or your common ports. 1024 to 49151 are registered ports. And then 49152 to 65535 are private and dynamic ports. Some of the TCP ports that you need to make sure you understand are the registered ports. 1863 is the MSN messenger. You also have 8008 and 8080 as alternate HTTP ports. The well-known TCP ports are 21 for FTP, 23 for Telnet, 25 is SMTP, 80 is HTTP, 110 is your POP3, 194 is internal relay chat, and 443 is your secure HTTP, and you'll see that listed as HTTPS in your URLs. The UDP ports you have registered are the 1812, which is Radius Authentication Protocol. Your 2000 is your Cisco SCCP or your Voice over IP. 5004 is RTP, Voice and Video Transport Protocol, and then your SIP, which is another Voice over IP, is 5060. Also, some of your well-known UDP ports are 69 for TFTP and 520 for RIP. You will see these numbers again probably on the chapter exams, possibly even on certification exams. Your registered TCP/UDP common ports are 1433 for MS SQL and 2948 for WAP. Then you have your well-known TCP/UDP ports are 53 for DNS, 161 for SNMP, and 531 for AOL Instant Messenger. And yes, people still use that. Packet filtering, sometimes called static packet filtering, controls access to networks by analyzing the incoming and outgoing packets and passing or stopping them based on your static criteria. Your router acts as a packet filter when it forwards or denies packets according to filtering rules. And when the packet arrives at the packet filtering router, the router is going to extract certain information from the packet header and make its decisions according to the filter rules as to whether the packet can be passed through or has to be discarded. And the packet filtering works at the network layer of the OSI or the internet layer of TCP/IP. As a layer 3 device, the packet filtering router uses rules to determine whether or not to permit or deny the traffic based on a source or destination IP address, either your source port or your destination port, and the protocol of the packet. These rules are defined using the access control list, or your ACLs, which is what this chapter is about. Recall that an ACL is a sequential list of permit and denies that apply to IP addresses or upper layer protocols. And the ACL can extract the following information from the packet header, test it against the rules, and it makes its allow or deny decisions based on it. It looks at the source IP, the destination IP, and the ICMP message type. The ACL can also extract upper layer information and test it against its rules. Your upper layer information includes your TCP/UDP source port or your TCP/UDP destination port. And if you'll watch the simulation, you'll see how it handles the allowed and the denied packet filtering. An example of packet filtering, if you had the scenario where only permit web access to users from network A in this diagram and deny web access to users from network B. Permit them to have all other access. So we're going to look at this diagram we have here. And for this scenario, the packet filter looks at each packet as follows. If the packet is a TCP synchronized from network A using port 80, it is allowed to pass. All other access is denied to those users. If the packet is a TCP synchronization from network B using port 80, however, all other access is permitted. This is just a real simple example. You can permit and block things based on the port level, and to do that you would use an extended ACL. That's going to be covered later in this chapter. An ACL is a router configuration script that controls whether a router permits or denies packets to pass based on criteria found in the packet header. ACLs are among the most commonly used objects in the Cisco iOS software. Your ACLs are also used for selecting types of traffic to be analyzed, forwarded, and processed in other ways. As each packet comes through the interface with an associated ACL, that ACL is checked from top to bottom, and then the packet is handled accordingly. By default, a router does not have any ACLs configured, and therefore there's no filtering going on of the traffic. The traffic that enters the router is routed according to the routing table and isn't checked against anything. Here are some of the guidelines for using ACLs. Use ACLs in firewall routers positioned between your internal network and your external network, such as the internet. Use ACLs on a router positioned between two parts of your network to control traffic entering or exiting a specific part of your internal network. Configure your ACLs on border routers situated at the edge of your networks. This provides a very basic buffer from the outside network or between a less controlled area of your own network and a more sensitive area of your network. Configure your ACLs for each network protocol configured on the border router interfaces. And you can configure ACLs on interfaces to filter inbound traffic, outbound traffic, or both. You'll notice here in this example it says what is an ACL. This is showing where you could select and place your ACLs and what they would do. On this particular one, there's no video to the switch 1 and no access to switch 2 for switch 1. On router 2, the ACL allows email deny telnet. So any email that comes in, it allows, but it denies the telnets. Here on router 3, going over to the HR subnet, it allows HR access. The control list from router 3 to the switch 3, it allows no updates, no FTP, and no web. With the particular situation that we had with 2 interfaces and 3 protocols running, this router could have a total of 12 separate ACLs applied. A general rule for applying ACLs on a router can be recalled by remembering the 3 P's. You can configure 1 ACL per protocol, per direction, per interface. So the 3 L's are 1 ACL per protocol, per direction, per interface. Per protocol is to control traffic flow on an interface, and an ACL must be defined for each protocol enabled on the interface. 1 ACL per direction. ACLs control traffic in one direction at a time on an interface. 2 separate ACLs must be created to control inbound and outbound traffic, because those are 2 different directions. 1 ACL per interface. ACLs control traffic for an interface, for example, your FA00. Here you'll see the 3 P's for using ACLs again listed out. Pay attention to the 3 P's. Learn what the 3 P's are. You will see the 3 P's again. Writing ACLs can be a challenge and complex task, and every interface can have multiple protocols and directions defined. The router in this example has 2 interfaces configured for IP. It's got AppleTalk and IPX. And the router could possibly require 12 separate ACLs, 1 ACL for each protocol, times 2 for each direction, times 2 for the number of ports. So you see it can get very complicated, but don't get overwhelmed by this. ACLs perform the following task. We're going to limit network traffic to increase network performance. For example, if your corporate policy does not allow video traffic on the network, ACLs that reduce the network load and increase the network performance if you make sure that the video can't go. It provides traffic flow control. ACLs can restrict the delivery of routing updates. If updates are not required because of network conditions, bandwidth is preserved because it's not flooding your bandwidth with information it doesn't need to keep up with. Provides a basic level of security for network access. ACLs can allow one host to access a part of the network and prevent another host from accessing the same area. For example, access to the HR network can be restricted to selected users. You just don't want anybody on your HR information. Decide which types of traffic to follow or block at the router interfaces. For an example, ACLs can permit email traffic but block telnet traffic. Control which area of the client can access on a network, and screen hosts to permit or deny access to network services altogether. ACLs inspect network packets based on criteria such as source address, destination, protocol port numbers. So keep this in mind. Alright, how your ACLs are going to work. The ACL, as we've said, define the set of rules that give added control for packages that enter inbound interfaces, packets that relay through the router, packets that are outbound, go through your interfaces on your routers. The ACLs do not act on packets that originate from the router itself, so it doesn't even look at those. Okay, so ACLs are configured either to apply to inbound traffic or apply to outbound. Remember, they don't apply in both directions for one ACL. So keep that in mind. Your ACL statements operate in sequential order, and they evaluate packets against the ACL from the top down, one statement at a time. The figure shows on the right here shows the logic of an inbound ACL. If the packet header and an ACL statement match, the rest of the statements in the list are skipped and the packet is permitted or denied as determined by the match statement. If a packet header does not match the ACL statement, the packet is tested against the next statement in the list, and it goes on through all your ACLs to see what it matches. The same thing for outbound traffic. It'll go through the sequential list of the information that's in those ACLs. So let's look here at this one, the packets to interface in the access group, and we'll watch how an inbound ACL would work. It would come and it says, does it match the first test? Yes. And then it would come down here and it would decide if it was going to permit it or deny it. Does it match the second? Match the third. If it hasn't matched any of the ones that you have in the list, and you can have more than 3, this is just a short example, then it's discarded. Outbound is the same way. It looks to see where it needs to go, and if it gets discarded or if it meets the yes statements, it continues on. If it's not, it's either dropped or sent out based on the ACLs you have set up. ACL and routing and ACL processes on your router. Here in this example we have frame arrives on a router interface. We look for the layer 2 address match. If it does not match, it is dropped. If it does, it looks at the ACL on the interface. If it is, it goes to the statement list match, and it either is a default deny or it moves on. If it is not, it comes over here to the route packet to the outbound interface to see if it matches there, and it continues on. As you can see, there's a lot of steps that your router takes, so it's important that you get your ACL set up correctly. The implied deny all traffic criteria statements, if you don't say it's allowed, it's implied that it's denied, if that makes any sense. At the end of every access list is the implied deny all traffic criteria statement. It's also sometimes referred to as the implicit deny any statement. Therefore, if a packet does not match any of the ACL entries, then it's automatically blocked because it's automatically implied that it is denied. There are 2 types of Cisco ACLs. You have your standard ACL and you have your extended ACLs. Your standard ACLs are going to allow you to permit or deny traffic from a source IP address, and the destinations of the packet and the ports involved do not matter. Here's an example of an ACL with a permit. So this access list 10 will permit 192.168.30.0 0.0.0.255. So this is going to permit this source address. So anything that's coming here and that meets this criteria is allowed. So on that network, because of the implied deny any at the end, all the traffic is blocked with this ACL. Standard ACLs are created in global configuration mode. An extended ACL filters IP packets based on several attributes. For example, the protocol type, the source and destination type of the IP address, the destination IP address, source TCP or UDP ports, destination TCP or UDP ports, and optional protocol type information. In this particular one, the source and destination IP addresses are looked at. We've got access list 103. We're going to permit the TCP from the 192.168.30/24 network any equals 80, and that is your port 80. How a standard ACL works. The standard ACL is a sequential collection of permit and denies. Everything is sequential. It goes in order, so it's important that you key in your ACL commands in order that makes sense. The destination of the packet and the ports involved are not covered on this one. So the two main tasks involved in using ACLs are as follow. Create an access list by specifying an access list number or name and access conditions. If you give it a name, it tends to be easier to remember what it is that access list is for instead of trying to remember what that number stood for. Then you're going to apply the ACL to the interface or terminal lines. Also, you can add remark statements which will help you keep up with what this ACL list is supposed to be doing. Using numbered ACLs is an effective method in determining the ACL type on smaller networks, but again, if you give it a name, it's just easier to remember what you're doing. When you name an ACL, names can contain alphanumeric characters. It's suggested that the name be written in caps, and names cannot contain spaces or punctuation and must begin with the letter. You can add or delete entries within your ACL. The proper placement of an ACL to filter undesirable traffic makes the network operate more efficiently. Make sure that you've read through this information so that you know the most efficient location of your ACL. For the standard ACL here on this one, you'll see where they located it. For an extended ACL, they've located it a little bit differently. So make sure you read through that section so that you understand it. Some of your general guidelines for creating your ACLs. For best practices, you have your guideline. Base your ACLs on the security policy of the organization, which means you need to know the security policy of your organization. Prepare a description of what you want your ACL to do. That'll be in your remarks so that you understand what it is it's supposed to do and it's easier to find what it's not doing. Use a text editor to create, edit, and save your ACLs. You can do this in Notepad like you're doing your router configs now. Test your ACLs on the developmental network before implementing them on a production network. This doesn't necessarily apply in the labs because you're not going live to a large network. If you were actually doing this in the real setting, it would be best to develop this and test it on a testing system before you took down your whole network. Here's an activity that you need to go through. There's actually 3 of them here. You can reset them and you can check to see how well you've done. This is a good place to practice for any tests that may be coming up. Entering criteria statements before beginning to configure a standard ACL. Again, understand the importance of the ACL itself. Here's an access list 1 that's going to permit information. Here's access list 2 with the permit information and the deny any. When you configure your standard ACL, in this figure it's going to show you how we've done it. We take access list 2, we deny this host, we're going to permit this network, we're going to deny this network, and we're going to allow this network. And it's going to go through in that order. It's first going to look at the deny, then it's going to look at the permit, then the deny, and then the permit. and if packets are permitted, they are routed through the router to an output interface. If the packet is not permitted, they are dropped at the incoming interface. Configuring your standard ACLs, you'll need to read through this information to understand the different syntax that you're going to use. This information here, you can scroll down to see more information. You can remove your ACL. Here an ACL statement exists. You'll see that it's a standard IP access list 10, permit, and here this is. So in order to remove it, you can just do no access list 10, which takes this list here out. You'll want to put remarks in. Here we're configuring a access list, so we're going to say access list 10. Here's your remark. You start it with the remark statement. You're going to tell it that it's to permit host from the 192.168.10.0 LAN. So you tell it that access list permit 192.168.10.0, and then you exit and you can show run. ACL wildcard masking. The ACL statements include mask, also called wildcard mask, and it's a string of binary digits telling the router which part of the subnet number to look at. Okay, so here's your example of wildcard masking. And here is another example. Applying standard ACLs to interfaces. Your standard ACL configuration procedures are shown here. You can read through those. The syntax is access list, the list number, permit. Here is your network that is permitting. Then you have your interface FA00, and then you're going to use an IP access group. So this one is going to be IP access group 1 out. And to remove the IP ACL from an interface, you just enter no IP access group. Here's this example. We have access list 1. It's going to permit this network. It's going to do it on interface SO000, so the serial interface, and the IP access group 1 out, so it's going out. Here's another one. It has a deny and a permit statement. And this one also has a deny and permit statement. You can use your ACL to control VTY access. Here on this particular example, we've got our access list 21. It gives us a permit statement and another permit statement, so it's letting in two networks. We've got our deny any. And then we've got line VTY04. You got your password, you log in, and then access class 21N. Okay. You can edit your numbered ACLs. Do it by the no. It turns it off. Then you can change what it is you need it to say and recreate it that way. Again, make sure you put your comments in there with the remark statements. I can't stress that enough, because when you go back and do your show run, sometimes if it's been a while, you may have forgotten why you created that ACL. So put your remarks in there and make them descriptive so you understand what's going on. You can create your named ACLs. So this one is an IP access list, standard or extended name. You have your permit, deny, and your remark, and then your group. Here's an example. I've got IP access list, standard, which means it's a standard ACL, not an extended ACL. We have it in all caps and we have an underscore, but it doesn't start with it. We've got our deny, we've got our permit, we're telling it which interface and which group. You can do show access list and you can see what that particular access list does. This comes in handy if it's not working the way you think you keyed it in. You can do your show access list and see how the router itself sees what you've keyed. You can edit a named ACL. This is what the router output will look like if you go in to edit that. Comes in handy. Here's a packet tracer that goes along with this. I've assigned several packet tracers for this chapter, and there are several labs assigned as well. You need to test your packets with your extended ACLs to see if things are working the way you want them to work. You can test ports and services. This one is using port numbers and this is using keywords. Instead of telling it port 23 or 21 or 20, we're telling it telnet, FTP, or FTP data. Configuring your extended ACLs. You'll notice that your command line's a little bit longer. You've got your access list. On this example is 103. We're going to permit TCP for this network any, and it's going to come through port 80. So you can definitely see that there's more information here on the extended ACLs than on your standard ACLs, because remember, standards do not go by ports. To apply an ACL, you have your interface. You're going to assign which group, whether it's affecting inbound or outbound. Here's the deny FTP statement so that you can see what it looks like. See, it's denying through port 21 and 20, because remember, FTP has both ports. One's FTP and the other one is the FTP data. Here's what a deny telnet looks like. You could have also said telnet here instead of 23. Creating your name extended ACLs is very similar to the way that you created it when you did the standard named. So we've got IP access list extended, and you've given it its name in all caps. You give the information, you assign the IP access list. Here's another one, extended browsing. So on this one we have two different ones. This one is for when they're surfing, this is when they're browsing. There's a packet tracer that goes along with naming your extended ACLs. There are different types of complex ACLs. You have your dynamic, which is lock and key, and the users that want to traverse the routers are blocked until they use telnet to connect to the router and are authenticated. You have reflective ACLs that allows outbound traffic and limits inbound traffic in response to sessions that originate inside the router. And you have time-based ACLs. They allow the access control based on the time and the day of the week. Make sure you read up on what the dynamic ACLs are. And it has several different examples. It gives you your configuration along with what the topology looks like when you are implementing this. The same for reflective. Time-based. Some troubleshooting of common ACL errors. This error 1 has no connectivity. Here's error 2. And these are good examples. You can go in and look over these Make sure you understand what caused the error. Here's an activity to help you figure out what's going on. You just go plug in your little information where you think it should go, and then you can reset it. You have activity 2. You're going to put in your commands, activity 3 and activity 4. Again, these are good exercises. You have your hands-on lab for basic. You have challenge. And you'll notice there's also packet tracers that go with these. And troubleshooting. Make sure you review the summary. Again, the quiz at the end is a great place for you to test your knowledge. And again, I don't see the results of that. That is for your information. And then you also have an integrated packet tracer. I do not have that assigned. And then take the quiz. You can take it as many times as you want to until you feel comfortable, and I recommend you doing that before you do the end of chapter exam. Good luck with the ACLs, and let me know if you have any questions.